Okay, this video is going to go over finding the quadratic features from an equation in standard form. The features we're going to look for are the y-intercepts, the x-intercepts, the line of symmetry, the vertex, the domain, and the range. So starting off, since they gave us this function in standard form equation, we're going to start by finding the y-intercept. Okay, so the y-intercept is always written as I do nothing and I get some value. Okay, so this one's easier to do first because when I input a 0, we can quickly see what we're going to get. Okay, some of you might need to write this out, but 0 times 0 is 0, 30 times 0 is 0. That's why we say it's easy, because those two parts go away and we're left with the 200. Okay, so our y-intercept is 0, 200. Okay, you'll see me on the side checking my work as I go through this. On a test, you want to be able to do this, but since we are just practicing, I'm going to show you how to check your work as you go through on Desmos. Okay, we also knew the standard form equation, so I'm going to write that out here, and we should be able to check that indeed our y-intercept is 30 after we write our equation in. Yep. So there it is. Okay, so next thing we're going to look for are our x-intercepts. Okay, so x-intercepts are always in the form of I do something to get 0. Okay, and this idea of getting 0 is really important because the easiest way to get 0 is by multiplying by 0, and so we use this thing called the zero product property. If I can find factors of my function, I can make one of the factors equal to 0, and I know that that will give me an output of 0. So that's why we factor this. So if I find a factor of x squared plus 30x plus 200, and I ask it to be 0, I find out what I plug in to make that one factor 0, then I can guarantee that I'm going to have an output of 0. So we're going to factor this. So x squared plus 30x plus 200 is our function, our equation. Okay, and I noticed that a is 1, and then we have a c of 200. So I don't have any common terms here. So that greatest common factor is just 1. And so that means that this would be my a term, this would be my b term, and this would be my c term. Okay, so since my greatest factor is 1, I can jump into the big X. A and c go on top. So we're going to end up with 200x squared. And then on the bottom, we're going to have 30x. And I'm going to go through this process. If you already know what the answers are, you can go ahead and put them in there. But I'm going to go through a process of figuring this out, which are finding the factors of 200. So one factor of 200 is 1 in 200. When I add these together, we do not get 30, so I'm going to keep going. 2 times 100 also gives us 200, but when I add them together, we're at 102. Notice 102 is closer to 30 than 201, but it's not close enough. It's not 30, so we're going to keep going. 200 divided by 3 doesn't turn out nicely, so we're going to ignore that one. 4 times 50, that gets us 54. We are getting very close to 30 now, but we're not there yet. 5 times, I know that 5 goes into 120 times, so it's going to be 5 times 40. Now we're at 45. We're closer, and we're getting closer and closer. 6, because 3 doesn't fit in there, I know that 6 won't fit in. 7 is not going to fit in. And all these things you can check with your calculator. 8, 4 and 2 do fit. So what fits into 208 times is 25. Oh, we're so close. So that added together gets us 33. We want 30, so we're almost there. 9's not going to work once again because 3 didn't work. 9's not going to work. Right? So the factors of 9 are 3 and 3. and then 10 times 20 gets us 200. And when I add these together, we do get 30. Okay, so those are going to be my values here, 10x and 20x. All right, so now I know the values that are going to go into my area model. Some of you know the shortcut that if A is 1, you're pretty much done. But I'm going to work through this just in case you need that extra guidance to verify that it does work. Okay, so we always put A in that top left corner, which is x squared. And then C goes in the bottom corner. Over here we notice that C is 200. And then the two values we found go in the other two boxes. So we found 10x and then 20x. Okay, 200, not 20. Okay, this is nice. I see the x's line up across this way. So they both have x's this way. These both have x's, so I'm going to take out the x there. X times 20 makes 20x. So I've taken out the 20s going up and down here. I need to finish by finding something else they have in common. 20 times 10 gives us the 200, and then 10 times x does give me 10x. Okay, so what we just discovered is that x squared plus 30x plus 200, which is our original equation, is equal to x plus 10 times x plus 20. Okay, so we want to check that out because now we can say that if x squared plus 30x, remember we're looking for our x-intercepts, that means we want it to be equal to 0. That's the same thing as saying that x plus 10 times x plus 20 is 0. And so we can see that there's two ways to do that, right? So I can make this factor 0, or I can make this factor 0. I can make the x plus 10 0 by having an x of negative 10, or I can make x plus 20 0 by having an x of negative 20. So I want to verify that by inputting it into the original equation, and I can check that. Okay, so negative 10 squared plus 30 times negative 10 plus 200, and we're trying to see if it equals 0. Okay, negative 100, or sorry, negative 10 times negative 10 is 100. Negative 10 times 30 is negative 300. And then we do see the 100 and 200 make 300. And so they will end up equaling 0 because 300 minus 300 is equal to 0. Okay, let's check the other one. Okay, so next one is negative 20. Also negative 20. Notice that when I choose an input, I keep that input consistent for the whole problem, or for the whole equation. And then we're trying to find out, does this indeed give us 0? This one we're checking. Sorry about my penmanship. Okay. So in this case, we have 400 plus negative 600 plus 200. That same thing is going to happen here. Let me make that a little bit cleaner, sorry. 200. And then we have the 400 and 200. That makes 600 minus 600, which indeed is 0. And so it does check. Okay, so those are the two values we can input to get 0. That's because we factored it and we asked each of the factors to be 0. One way to do that was with a -10. The other one was with a -20. And so let's write that out. So when I plug in a -10, we expect to get 0, and that one hits that x-intercept, sorry. And then when I plug in or input a -20, we get 0, and that lines up. Okay, so we have our y-intercept, our two x-intercepts, and we actually wrote our factored form. So I'll write that down here. Our factored form we discovered was plus. Notice that it's plus here because when we plug in the -10, we want it to be 0. And so it's going to be x plus 20 in the equation. Okay, that works because when I input a -10, we get 0, and when I input a -20, we get 0. So now that we have our x-intercepts, we can find our axis of symmetry by finding the middle of these repeated outputs. Okay, the repeated outputs in this case are 0 and 0. Okay, so to do that, one way to do that is to make a list and then work your way towards the middle. Okay, so I'm going to demonstrate that first, and then I'll demonstrate a shortcut. So there we go. One on each side until I find the middle, and so that's the only one that's left. Notice I have 5 on the left and then 5 on the right, and so -15 has to be the middle. That would mean that my input will be -15, and we don't know the output yet. Okay. Another way to find the middle of two values is to take their average. Okay, so we take our two x-intercepts, which are -10 and -20, and I add them together. To take the average, we divide by 2. We get -30 over 2, which is also -15. Okay, so either way, you can find the middle by working step by step, or you can find the middle by using some more advanced mathematics. Either one's fine. The important thing is you do something that you understand. Okay, don't just do it because someone told you to. Do it because you understand it. Okay, all right. So now, how do we find the output? Well, this is our axis of symmetry, by the way. So we can write x equals -15 for our axis of symmetry. And this line should be right in the middle of our parabola, which it is. And notice I got to find this output. I want to calculate -25. And the way we do that is we actually put that value back into our original equation. The original equation was something squared plus 30 times something plus 200. And we learned that the axis of symmetry is -15. And so we can simplify this, and we should be able to get the height or the output of the vertex. So 15 times 15 is 225 plus 3 15s is 45, and it's negative, and then plus 200. All right, well, this becomes together, this becomes 425, and then that's minus 450. 425 minus 450 ends up being -25. So our output ends up being -25. So that means our vertex is at -15, -25. Let's check that. Okay, so -15 and then -25, and it lined up exactly where we wanted it to. Some of us know the vertex form. ax minus h squared plus k. So I want to walk us through the thinking behind the vertex equation. So each time we have a parentheses in an equation like the vertex form, we're always taking the x value and making that parentheses 0. Okay, so we'll start off with that. So what do you do to a negative 15 to make it 0? You add 15. Okay. Notice here that gives us a line. So that's why we have to square this. We don't want a line, we want a parabola. Okay. And so that forces it to be a parabola, which is nicely aligned with our axis of symmetry. Okay. But we didn't want 0, right? We use the parentheses to get 0. There's this plus k on the outside. What that does is it moves it up and down. And so we didn't really want it to be 0. We wanted it to be down 25. And now it's lined up with our original equation. Okay, so that's very nice. Okay, so our domain for linear, exponential, and quadratics is all real numbers. Unless there's some sort of context that goes along with it. Most functions have an input of all real numbers. That means I can plug it in the calculator and it's going to give me something. The only time that we would ever not have that is if we're dividing by 0. Okay, so range is everything we can possibly get. So it's all the outputs. We notice that we do have a bottom. So that means that the y has to be bigger than or equal to that negative 25. And notice how it shades in the range. Okay, so you'll notice that I used Desmos to check my work as we went through this, but on a test you will not have Desmos. So how do you check without Desmos? So we actually went through and we verified our y-intercept in the beginning by inputting 0 using the definition of a y-intercept, what we get when we do nothing. So we know that has to be our y-intercept. Our x-intercept is what we do to get 0, and we check that also. Okay, so we know our x-intercepts work, our y-intercept works, and our vertex is always in the middle, so that's something we double check. And according to our equation, we plugged it back into the original one and we did get a negative 25. So I'm pretty confident that our points are correct. I'd like to finish by checking our vertex form. The other point other than the vertex to check it, and the easiest one tends to be the y-intercept. So our vertex form was x plus 15 squared minus 25. And our y-intercept was, if I do nothing, I get 200. So we want to check that. So when we plug in a 0, we expect to get 200. So let's try that. So 0 plus 15 squared minus 25. 0 plus 15 is just 15. So 15 squared minus 25. 15 squared is 225. And we can start seeing that indeed 225 minus 25 does give us. So that's the last part for checking our